So far we've learned how to express logic with conditionals. We've learned how to break our problem up into functions. But one of the things that we haven't learned how to do is how to repeat the same activity over and over and over again. A process that we might call iteration or repetition. This is a real pity because that's one of the things that computers are really good at. While humans aren't very good at doing the exact same thing over and over and over again, we tend to find it boring and we lose interest and then we start to do a very bad job at it. Machines are remarkably good at this. On the plus side, it turns out that we can create iteration or repetition using just what we know so far. We don't have to introduce any new constructs in Scala. And there are lots of different ways that you can do this, and we will see multiple approaches to doing iteration or repetition in Scala. But the first one that we're going to introduce, we're introducing first simply because it doesn't require anything else. So the approach we're going to take is to use what's called recursion. And in this video, we want to talk about recursion from a mathematical standpoint. And we'll start off using a function that hopefully you're all familiar with, and that is factorial. So one way to define factorial is to say that n factorial is 1 times 2 times, and then we cheat a little bit and say ... and give an n. Okay. If I were trying to teach someone young how to do a factorial or what it means, this is probably what I'd show them first. Now, mathematicians have a different notation that we can use. You can use this pi symbol to represent repeated multiplication. And so this gives us the same expression without the vagueness of the ... This is kind of more formal. And in some ways, this is closer to what we might express in a programming language using something called a loop, which we'll learn about later on. But math also gives you the ability to define this recursively. And what it means to be defined recursively is that the function is written in terms such that it depends upon itself. So here's a recursive definition of factorial. It says that n factorial is 1 if n is less than 2. Otherwise, it is n times n minus 1 factorial. Okay, so the factorial here is defined in terms of factorial. That's what makes it recursive. Another thing that we have to have when we write a recursive function is this situation here, this 1, is called a base case. Because if the factorial were only defined in terms of factorial, then you would never get to the end of the definition. It would just keep going forever. So you have to have some situation where it doesn't utilize itself for the next step. And recursion can be far more complex than this, but the basic rule is if you define a function in terms of itself, then you're doing a recursive definition. Also note that we change this value here. So the new factorial that we're calculating is n minus 1. And we want to be moving towards small n because our base case here is for n less than 2. So this kind of iterative step here is always moving towards the base case. And that's what we generally want to see in a recursive function. Let's take another example. And factorial is kind of a standard one, but it's worth looking at another one to help you give you an idea of how this works. So here's a function where we want the sum of all the squares from 1 to n. Okay. Once again, I'm start off with my ... notation. I can be more formal and use the sigma for summation. And this is probably something that you're more used to seeing than the pi notation for multiplication. So this is just the sum of all values where I goes from 1 to n of I squared, which clearly is the same thing as that. We can define this recursively using this definition. So once again, if n is less than 2, we're going to give back 1. In all other cases, we want n squared plus the function that we're defining here operating on n minus 1. So if I called this with 5, it would be 5 squared, or 25, plus this value with 4, which would be 16 plus this value with 3, which would be 9, plus the same value with 2, which would be 4, plus, and then when we go to the 1, we get to this, and so we have 1 plus 4 plus 9 plus 16 plus 25. And when we add them all together, that gives us the value that we wanted. We can do this in Scala. In fact, the code that we're going to write is going to be very similar to the mathematical notation in many ways. And we can write these things so that they will take whatever value of n, and we don't need to actually use any new constructs. We're just going to do it with our functions. Note that here in math we're defining functions, and the conditionals that we have. In some ways, the doing this in one case and this in another is the conditional. It's like our if, and we'll see how to do that in the next video.